Great. So officially, you're welcome to another session of our PLD discussions. And in today's session, we are looking at a practical approach to pointers in functions. So the last session that we discussed practical use of pointers. But today we just do a bit because I told you in the previous session that we are going to look at it in this session. So we'll take a look, maybe one example, then we'll move on to the arrays and strings because that's the focus for today's discussion. Okay. So for those of you who are joining us for the first time, you are welcome to this subgroup. And today, as I've said, is going to be a practical session. So you're going to see me using the online compiler known as Programmers C online compiler. That's what we use for our practicals. Then you see me switch to the board here if I need to explain some concepts. But the good thing is that we have already discussed these concepts. So arrays and pointers, we've already discussed them. That is the theory part. We've discussed the theory part, and the video is available on YouTube. We have links, I think, in the group. So once you're in the group, you can always grab the link. Or on YouTube, if you search for my name, you are sure to find the videos that we've published on YouTube. So you can always go back and make reference to the theory aspect of this discussion. But today we are focusing more on the practical aspect. So I said the very first thing we want to look at is using pointers in arrays. So if you can recall, pointers in functions. If you can recall, when we were discussing pointers, I made mention of the fact that pointers are basically like the normal variables we have, except that they are storing the addresses. So ideally, someone will ask, why would we even need pointers in the first place? Because we already have a variable that we can use, okay? And we explained the reason why we need pointers. And one of the reasons, as we explained, was that sometimes it becomes imperative that a function that we are creating should be able to modify the exact value that is stored in a particular location on our computer's memory. The challenge is that when we pass variables as arguments to functions, and I'm using these terms presuming that everyone here at least knows what these are. If you don't understand these words that I'm using, I mean arguments, variables, pointers, and the likes, you've already dealt with them. So hopefully you can always go back and watch them. That's why we do well to record our sessions. Okay, so in simple terms, if you have a function, we already know that to declare a function, we need to state the data type that the function will be returning. So data type, that will be returned. Then the name of the function. Then we have the parentheses, which everything in here is called an argument. So what I'm saying is that if you pass a variable as an argument, what happens is that it's actually a copy of that variable that we get. So we don't actually move the variable itself. We create a copy of it and use it in the function. That means that if this particular function, if you pass a variable to it and make changes to that variable, after making changes to the variable, it doesn't actually affect the original variable that you created because you created a copy of it in order to use it in the function. But there are times that you want the function of yours to be able to make changes to the exact variable that is inside or that has been stored inside the memory of your computer. And if you want to be able to do that, then you have to tell your function to go and pick the value in that specific location. And we refer to those locations as addresses. And what points to the address is known as a pointer. This means that instead of passing a variable to our function, we'd rather have to pass a pointer to that variable as an argument in our function. Once we use a pointer as an argument, all that we are doing is that we are telling our function that anytime you want to use this variable, don't just make a copy of it. Go into my computer's memory where this variable is stored, go and grab the exact value there. And if you need to make changes to it, make changes to the one that I have stored. That is basically what it is. So now let's get into our compiler. What are we trying to do? We are looking at practical, so let's say pointers in functions. Okay, in order to demonstrate it, I want to just create a sample function where we are going to pass a variable to it to demonstrate this before we pass a pointer to it. And hopefully this practical session will make you understand the difference. All right, so as we all know by now, we need to declare our variables. Let's declare a variable called a and assign it to the value 5. Assuming we want a function that is going to return an integer, and we'll call that function test. So the function is called test, and we are going to pass an integer argument or an argument of integer type. Okay. Excuse me. Okay, so we can go on to say this, or better still, we can take this particular function outside. We can take it outside our main, then we'll pass a prototype up there. Okay. No, let me try this because I've not done that before. Declaring the function within, I think it should work, but I've not done that before. Okay, so let's see what will happen if after declaring int test integer a. Okay, so this our variable is what we are passing, and in here we want to increase a. Okay, then this increment operator too we've discussed in a previous lesson. All right, so hopefully you know what it does. It just adds 1 to the value that was in a. So by doing this, okay, no, let me print instead of return. Let me print instead of returning it so that we can see. Okay, let's go and then do a print. Print f of an integer, comma, we are printing a. So we are printing the current value of a. And what you realize is that we have added 1 to a. So those of you who do not know, this basically means a, that the new a is equal to the previous a plus 1. That is what plus a means. Okay, so it means that we are going to take 5 and add 1 to it. So this a is supposed to print as how do you call it, 6. Let me run it and see. Great, I'm not getting any output. No error. So as I said, I haven't tried this a function within the main before. Probably there is something that I should do before it works, but let's try it outside, then pass the prototype up here. Hopefully this should work. Why is it not printing out something? Yes, once you are here, okay, so it should, let's return this, then I'll print the value. Oh, return this. So hopefully return this. Okay, I get it. I didn't even call the function in here, which obviously wouldn't work if you haven't called it. Oh, okay, so I think the problem was because I didn't call the function, so I should call it and pass this to it, a to it, but it's returning this, and say, let me assign value integer value to be printed is equal to this, then I'll print this variable and say print f of, I think I copied that, print f of. Please, when I'm doing these things, I don't consider Betty documentation and Betty style, so kindly pardon me. Otherwise, it will take forever here. Okay, so hopefully this should print something for us. Okay. Yes. So we realize that it's printed 6. The reason it's printing 6 is because we are adding this to it. Okay. We are adding the plus to it, and that is after we execute the function. This is inside the function. Okay, we are returning the value to this. But even though we have increased A in this case, if we go ahead and do outside, so now this has been done, and we all can see, if I run it again, you can see that this is 6. Okay, if I go ahead and print A, what do you think I'm going to get? Yes, anyone? What do you think I'm going to get? Just print A.
You
What is it? Steven,
get
I'll get what?
5.
5. Good. So that is what I want us to understand why. So Steven, can you suggest why? Like, let's just hear from your opinion. Why would we get 5?
Yeah, because you only change the value in the function call.
Okay.
The,
All right.
the increment didn't happen in the parameter of the function.
Okay. All right. So thank you so much for your submission. I'm tempted to do something, but let me run this before I try that. So run both of them, and you see our A that we are printing outside the function is giving us 5. But when we print A inside the function, it gives us 6. I think we can even actually make a print in it. Let me cut this. I just want to try simplify these things. So if we print A here, I think it should still give us. We don't even need to call this any longer. Just run it. Let me comment this out. Run. Good. Okay. So this test, because in here we are printing already. Okay. It's just printing A. Printing A, as you can see. This function is to print A. I'm tempted to do one thing. Pardon me to do it. Let me move this inside the main. I've not tried it before, so let me move it, and I think it should work. Okay, it's not going to work. All right, that's good. So as a programmer, these are the things that you should be doing. Like, try your hands on things, get to know why this doesn't work, why this works, will this work? Like, ask those kind of questions and try. Okay, good. So at least now we have a working code, and if I uncomment this, we're going to get 6 and 5. 6 and 5. But both of them are still printing A. This is a function in which A is incremented. So why is A 6 here? But when we come down here, it becomes 5. That is where the problem comes in. And the reason is because this function doesn't take this actual value. So it doesn't get to the memory and go and pick this value. When it sees this A, it's going and creates its own copy and says, okay, let me assign A to 5. Like, I've not gone to this memory. So it's like this function will create, call it a local variable. It will create something for itself, its own use. So we'll have a new memory for A is equal to 5. So if your A is equal to 5 was at memory location, say it's 4, That is a hexadecimal ending at 84. This A is equal to 5 may be stored at a different location. Your computer will choose where to keep it. So after it has been modified to 6, there's the new location that has a value 6, not this our location. And therefore, anytime we call our A, because this is what we know, it's still going to return 5. We haven't changed it. But if we want this one to go directly and go and pick the value here, then what we should do is we should rather pass the address or a pointer to it. So let me just quickly create a pointer called pointer PTA is equal to address of A. Okay, so if we have the pointer, then your function should take a pointer instead. So this time around, instead of passing A, I can pass PTA.
Hey, good day.
Yes. Good day.
I don't know. I just came, not like it's not up to 5 minutes. I don't know. I'm seeing some. It's looking like magic. I don't know what is happening really. I'm trying to grab something, but it's like I'm not seeing the whole functions here. I'm just seeing part of it. So I've not been able to understand what's going on. Please, sorry.
Okay. So all we are trying to do is explain why sometimes we need pointers instead of using variables in a function. That's all we are trying to explain. And we have created a function down here. Initially, we passed a variable to it. And realize that when we pass the variable and run our function, even though the value that we pass is changed, the actual value still remains. And I've explained that the reason why it is so is because when you create a function and pass the variable to it, the function makes a copy of that variable you pass to it as an argument. It makes a copy of it. So it doesn't use the actual one that you created. What you created has been assigned a memory location, which you can access on your own. But the function doesn't use that. It creates a copy of it and keep it somewhere else and uses it. So all the changes that a function can make to it will not affect the actual value that you stored, that you declared. So in our specific example, we had A is equal to 5. And this function was supposed to increase A by adding 1 to it. And when we printed out, it gave us 6. But after it has added 1 to that and given us 6, now 6. When we come here and we print A, it still gives us A is equal to 5. So the question is, why didn't it print A is equal to 6? And the answer is that because the function created its own copy of this, it didn't change the actual value here. It changed the value of the copy that it created. That is how come. So this function doesn't affect the original value. Now, what if you are interested in changing the original value with a function? If you are going to write a function that changes the original value, how do you go about it? That is where the option of pointers come in. And that's what we are interested in right now. So we are going to pass a pointer to this same function, then observe and see if after updating it, will it still give us 5 or is it going to affect the actual value? And what we are hoping to get is that it's going to affect the actual value, because this time around, we aren't using a copy of the variable that we declared. Rather, we are picking the exact memory location, whatever is a specific address. That is what we are passing to our function. And therefore, if we increment it, we expect the actual value to be incremented as well. I hope you understand it now. So there's our function. Currently, we are telling the function that we are going to pass a pointer. We are no longer passing the variable. We are passing a pointer. Hi.
Sorry for taking you back. This is line
Oh, don't
3.
worry. Okay.
This is line 3. Why do we
Okay.
have that prototype there? Why do you have that there?
Why do we have it there? Okay, so we have declared a function here. Okay, and I think during our session on functions, we discussed this extensively. Anytime you declare a function, what C actually does is that C is always concerned about the main. Okay, that is where it is concerned with. But when I explained functions in that lesson, I said that a function is more like an action word that the computer understands. But you can create your own functions. Okay, so user generated functions, sort of. And what happens is that if you and I right now decide that, okay, anytime we choose a particular word, it has a specific meaning. Say, if I say go, it means that we should all end our we should end the live stream and leave. If we have understood that, those who are not in this section, would they understand? If you go out and say go, who else will understand? If the person wasn't with us here, no one will understand. Okay, so for us to let all those other people understand, what is actually happening here is, sorry, you have defined a function here, and it does a particular thing. It adds 1 to the variable that you pass to it as an argument. But when you come into main doesn't know that you have declared any function. You have to explicitly tell main and any other function there that, okay, I've actually called, or I'm going to use a function that has this prototype. The function looks like this. This is how it's used. So this is like after we have created our own word, we go and paste it on a notice board where all our colleagues can see it. Okay, so let's assume here, after we have created our own function that we only those of us on this meeting understand, we can go into the Slack channel or the WhatsApp groups and paste it in there and say, from now on, when you see this word, this is what it means. So that is the purpose of the prototype. We are just trying to tell this main that, okay, anywhere you see test, this is the format. So that by the time main gets here and see test, oh, okay, so I know about this because it is here. Don't forget that C reads the program from top to bottom. Okay, so in most of our codes that we've been writing so far, what we do is that we keep these prototypes in what we refer to as a header file. The reality is that there are several ways of declaring the prototype. So this is one of the ways that you can put it here. I could have also created a header file and added it here, but this is one of the ways. And since it is not a bulky stuff, I could just pass it there. In fact, if I want it known to only main, I can actually also bring it in here to main alone. Then here, only main will understand. So if I go ahead and create another function down here, it doesn't know what that function test is. Okay, because you only declared the prototype to main. So if I put it up here, all I'm saying is that in this particular editor right now, this page that we are working on, anytime or any function at all that I create should understand that there is a function called test. Okay, and it takes this format. It's going to return an integer. It takes a pointer. I hope that is clear.
Yeah,
Are you clear on it? Okay, all right, good.
Yeah.
So glad. Now we can continue. Okay, so we are looking at our function taking up a pointer and printing out an outcome for us. Okay, if we go ahead and let me run this. Oh, okay, so let's debug the code. Someone, I wish we could see this whole code. I don't know. I want open your eyes very well and debug the code. What do you think the problem is? Let me just close up the space. For now, let me reduce the size. Oh, okay. What do you think is the problem? Why are we printing out this? When we expect to print out, what is it? return this. Okay. So you just go through the code and tell me what you think we are doing wrong. Yes, anyone?
I think it's because you're printing. Okay, where you did print of percentage D new line then comma, you're referring to the value A instead of the address.
Okay, but we are interested in printing the value because we want to compare whether this is going to change or not. So what should we do?
I think you're supposed to refer to the pointer itself and not just.
So how do I do that?
Yeah. You should do ampersand A there. You should put ampersand A there.
Do you think it should be ampersand?
Okay, ampersand will print the address and you put asterisk A.
Okay, I should put asterisk A.
Point.
Would that be all?
I think in our function we should
Then it should be P.
create a pointer.
I'm not sure it's supposed to be integer as
Okay.
D. I think it should be D now. That's the P, right?
What will P print? P is supposed to be printing address, right?
Oh, okay. Sorry.
All right. So you, yes, Denton, yes, yeah.
I think in our function test, in the parameter, it should take a pointer that will be pointing to the address of the of any argument that you should put.
Okay. Is that what it's doing right now?
Pardon?
Is that what it's doing right?
Sorry, is there anywhere you pointed the A to a pointer?
So here, this test, we are passing a pointer PTA to it. Right?
Yeah.
Okay. So now, what is the problem with this block of code?
I can't see your whole screen.
What is happening here? You can't see my screen. Yes, but
we only see a part at the same time.
Yes, that's the challenge right now. Yes.
The function.
So let me just okay, let me listen to you. Right, I'm listening to you.
The function test from the prototype is supposed to be returning a value, an integer value, but that function is not returning anything. So it's the main function is expecting an integer value to be returned from that function, and then in the main it's not now.
Okay, but that shouldn't be a problem here because we are not returning anything, and there's not going to be any segmentation error because if you don't return anything, the compiler automatically thinks you are returning an integer, so it will let you pass. Okay, that isn't the problem right now. The problem is that this line will execute whether we return something or not. That is what you are seeing it here. But what it is printing right now, it is printing this value for us. Is that the value we are looking for? That is the question. Because, okay, so at the end of the day, we want it to give us the 5 plus 1. But are you paying attention to this line? Is there something that is wrong with this line? Yes.
I think the asterisk before the A should be removed.
Which one here?
The one in the printf function, yes.
If it's removed, you're still going to get a similar case. Because once you remove it,
what if R plus plus A, we put asterisk?
Okay. Where will I put it? Here?
Yeah.
Does this remain this way?
It will still have a steps.
Will this solve the problem?
Yes. Yeah.
So those of you who didn't pay attention to the line, that was where the problem was here. Okay, because what we did there was now incrementing the address of A. Once we have incremented the address of A, it goes into your computer's memory and look for that specific new address that you have gotten and see whatever is there and print it out for you. So the unfortunate thing is that the memory, you can't guarantee that your memory is empty. So that you think if I go to the wrong location, I won't print anything. Almost every aspect of your memory, every address of your memory may have some information or some garbage data there. Okay? So at any point in time, if you mistakenly go to pick some information that's not what you are looking for, you are going to end up with some value. So that is what was happening to us by not using this and doing this. We had actually changed the address. So we are no longer looking for the address of this. We have incremented the address. So it goes into the computer and go and look for the new address that we have. Whatever value is in that new address, it prints it out for us. Okay, but since that's not what we are looking for, we have to tell you that we are looking for the value. So we are adding 1 to the value. Okay, this no longer holds. But anyway, now let's go ahead and experiment this. After we have increased this to 6, I wish I didn't delete the first one so that we'll compare both of them. When I print out this line, what should I expect? This last line, line 11. When I print it out, what should I expect?
6.
6. Okay, why 6?
Because you have transferred the address of A, and it is going to be manipulated when the function test is called.
Okay, good. So when we came into the function here, we actually brought the exact memory location containing this variable 5. A is equal to 5. Okay, so every change that we make inside this test function, we are actually making it to where this has been stored. So if we change it to 5, then if you change it to 6, then it should print out 6. Do we get it? I wish I could. Okay, so let me quickly copy this and we just post it together. Where should I do this? Where should I do this? Okay, so let me go to Replex. Hopefully you'll be able to see my screen from there. Okay, POD on Irish and pointers. Okay, so this is the one that we just did with the pointers. Okay, now let's copy this whole thing, create a new file, say one main.c, then change these to the values instead of pointers. So even this, we don't even need pointers in here. Okay, so we'll pass A, then we don't need a pointer. You don't need a pointer.
It's
You
so
don't need.
tiny.
Oh, is it better?
White background is more better, please.
Yeah, it's better.
Okay. What did the other person say? I didn't hear. Okay. So this is the function that we have, and if we run this right now, GCC one in A out. This gives us 5 and 6. So the 5 is coming from this function that we have here. So this is printing out new value of A. Okay, then this is printing out the current as in here. So current value of A. But we realize that because we pass just the variable to it, the current value of A doesn't change. Okay, unlike in this case where we pass the pointer. When we pass the pointer to it, so we can go ahead and run this one too and say gcc main dot c. Then I should have even given it a different name. A left out. Okay, so you realize that it's the same code, but we are getting different results because in the first case with this particular one, we pass the variable. Once you pass the variable, please, all I want you to understand here right now is that if when you are passing an argument to a function, if the function happens to be taking just the variable and not its pointer, any change that you do will only affect that variable inside the function. When you come outside the function, it doesn't affect it. If you want it to affect it, then you should use the pointer. That is all that we are trying to learn and establish right now. And this example has shown us what that actually does. If you pass a variable to a function using the actual value, it makes a copy of it and work on it. When we say it makes a copy of it, let me try and illustrate this for us. So let's say this is a function. Okay, it's a boss. You are going to pass a variable called n to this function. So function. Then it will give you an output. Okay. But you declare this variable n to be 2. And this function is supposed to have n plus 1. Give you the outcome or print out the outcome. And what I'm saying is that when you get outside this function, if you decide to call n again, n will always be default to 2 because you pass n directly to the function. But inside the function, when you call n, it will now be 3. Inside the function created a copy of n. It didn't use this specific n. When we say it didn't use this specific n, remember that we have been talking about memory location on your computer. So when you declared n, what happened in the memory of your computer is that the computer gave some space, a particular space to store n. Say n is equal to 2. When you pass n as a value to the function on its own generates a copy of it. So it automatically also creates somewhere inside the memory n is equal to 2, which is different from your n is equal to 2 here. So it will operate on it and finish. As soon as the function is done its operation, this will be wiped out of the memory. So you still have only this. So after your function has finished working, if you go looking for the value of n, it is still 2. But if it is the process inside where the function is working, if you go and look for the value inside where the function is working, n has changed. And this n is actually the n that the function created. So anytime you run it, when this function is going to run, it's also going to create a copy of n somewhere. And now increment it and say, oh, my new n is 3. But that doesn't change this, your original value. However, if you decide that, okay, this n that I want to pass to my function, let me rather pass the address of n. Okay, so you pass the address of n, or a pointer to n to your function. By adding 1, this is going directly into the specific location where you kept n and coming to increase it. So it will change this to 3. So even after the function is done executing, Your n in your location is now 3. That's the difference. Okay, so I think when we start talking about strings, you see why this is important and how we've been using it in our various tasks that we've been doing. You realize that of late, most of the tasks that they give us, the functions take the pointers, and this is the reason. So when they ask you to write a function that will concatenate 2 strings, you couldn't do it if you didn't pass the pointer to it, because it wouldn't go to update the one in the memory of the original string. Okay, so that is the more reason why we need to understand this, and this will affect how we use functions in general in C. So this is a concept you need to understand. You need to know, when do I need to just pass n, and when do I need to pass pointer to n to a function. That is the 2 things you need to understand. So let me just ask the question. Someone tell us and we'll move on. When should I pass n to my function? And when should I pass the address to n to my function? Let's just know those 2 differences. As soon as we know those 2 differences, we are okay. Okay, it means that anytime you are going to work with a function, you know that here I'm supposed to use n, or I'm supposed to use a variable. But in this other case, I'm supposed to use a pointer to the variable. So when do you use the variable, and when do you use the address or a pointer to the variable? Yes, anyone?
You said when should we use the address of the variable in the function?
Yeah.
I think when we are working with integers, but if it's an array or a string, we just pass the name of the variable.
Not exactly. Not exactly. Yes, any other person?
I think
so there are 2. Yes. Yes.
I think in a situation where you want the changes reflected on the variable itself, you pass it.
Okay.
In a situation where you don't want the changes made in the function to be reflected on the main variable, you don't pass the pointers.
Okay. Okay. All right. So that is all I've been trying to preach. Please, let's try and understand that. It is the main reason why we are doing this session. When you want, if you have declared, let's say, a variable, okay, so assuming I've declared a variable, say v is equal to 3, and I'm going to create a function. The question now is, should I pass just v to this function as argument, or should I pass the pointer to v? Okay, so integer. That's what we are trying to find out, and I'm saying that you should know the reason why you choose each of them, or any one of them. So the 2 can be used. Don't get me wrong. It's not like one is better than the other. The 2 can be used, but the question is, in what situation or scenario will you use this over that? And the answer is that there are times that you want to operate on this, okay, but you don't want to affect the original value that you created. You don't want to affect it. So that is the original value. We're going to do our calculations and things, but we will still need that value. So let me give a practical example. Let's assume that you ask the user to type their age. So you created an integer variable called age. Okay. An integer variable called age. Then you assign, the person typed their age. So let's say 40 years. Okay. That's what they did. Then you want to calculate something. Maybe you have a function that calculates whether how many years the person is going to need to go to pension. Assuming age for pension is like 60 years. So let me create a function called pension, and I'm going to pass But the question is, should I pass age as just the variable age or as its pointer? Okay, so should I go with just the variable or its pointer? That's what we are trying to achieve. Do we pass it just as a variable pointer? And how we are going to determine that is this age variable. Would we still need it after this function has finished running? If we still need it to be 40 after this has finished running, then we shouldn't use a pointer because we will have to keep this at a person type. Okay, so a practical case would be, what if we are trying to calculate another two? So let's say health risk. I'm just assuming. Let's say health risk is also a function that will run after this function has run. Then inside here, we are passing age to it. If I pass this age, all that I'm saying is that once I'm using age as a variable, it means that originally my age will not be affected, even if this function changes age. So assuming this function is going to return or maybe print or add, let's say this function will add 20 to the age and say the new age is equal to 60 years. Okay, if this function is going to end up having age is equal to 60 years inside its definition, once I didn't pass the pointer, all I'm saying is that the function created a copy of this my variable. So it's not using this actual variable. So when I come here and I go ahead to use age, the age here is still 40. Pay attention. I didn't use the pointer. I used just the variable because I'm going to need this exact value after I do my calculations here. Maybe there are other functions too that will need the exact value. I need my age to always remain 40, irrespective of which function works on it. If that is the case, always pass just the variable. But in the case where I need this function to work, give me the value before I come to use it here. So a practical example of that case would be if I declare a variable called sum is equal to 0. Okay, integer variable called sum is equal to 0. And I give another function. Let's say I create a function, add as a function. I'm passing sum to it. And what that this add function does is that it adds 10 to sum. At the end of the day, it's going to return sum is equal to 0 plus 10. So sum is now 10. If I have another average, and this average requires the current value of sum after being operated on this function or being operated on by this function, then in that particular case, I need to pass the pointer to sum. I don't know if we are getting the scenario. I want you to understand this because it's the basis for almost every other string and array questions when it comes to dealing with functions. In this our case, I passed just age because I didn't want to alter this age value. Everywhere I use age, I want it to remain 40. Every other function that I use age, I want it to remain 40. So I can't pass the pointer to it because when I pass the pointer to it and this function changes age, my age is now 60. So I can't really use it here as I wanted. In this our sum example, I wanted the sum to be changed anytime a new number is added. So since this has been added, I now want the sum to now be 10. So the sum that I will pass to this average should be 10, not 0. So if I had not used the pointer, I will still be having 0 in this average function. Please, do you understand? Any questions on that? There are two arms. Okay, even if you don't understand, please, there are two arms. The first is that use just the variable without a pointer if all you want is that your variable shouldn't change its original value. because you may need the original value in subsequent parts of your program. You need the original value. You need to keep the original value. If you need to keep the original value, don't pointer. If you need to update the original value, that is, your function is going to update the original value, then pass a pointer instead. Do you understand that?
Yes.
Okay. Okay. Glad that it's clear. So now when you go back to any of the questions on the task on strings and stuff, you realize that the function is usually something like this. Okay, maybe S. All that we are doing is that whatever S was assigned to here, okay, whatever it was assigned to here, this function is actually making the changes to this. So if you write your function with this to maybe change the value, I remember we did something like that, where we changed this was now equal to maybe something else. After you have done something like this, all you have said is that the value here has changed. So if I go ahead and print S, I'll find something different from what is here because this function has changed it. If I didn't use the pointer and I just passed S and did this, if I finish outside this function, when I go ahead to print my S is going to still give me the exact thing that is here. It's as simple as that, okay? So hopefully, if you have any questions, you can ask. Otherwise, we have to move on to Aris. Yes, if you have any questions, just go ahead and ask.
Yes, I have a question.
All right, let me listen to you.
When we're using a character data type for a variable, for let's say we're using it in a function, and then we're passing a pointer to a variable, let's say like S. When we're using it in that function, I noticed that like we don't use the asterisk S again. We just use only S. Meanwhile, if we're using something like an integer, we still have to use that asterisk together with the pointer. I don't know if there is a reason behind that.
Okay. All right. So there is actually a reason behind that. And I think even in the last session, someone asked a similar question and I responded. But we are going to be dealing with strings, so hopefully we'll get there for you to understand. And okay, so please remind me, I'm talking about arrays. Okay, so it's part of arrays. The answer is in arrays. So we'll answer that, okay? Hopefully. I'll mention it. If I forget to mention it, you just ask that question. All right. So now we've actually dealt with arrays before. We dealt with the theory behind arrays. What arrays are, why we need to use arrays, when we need to use arrays. Please, anytime any new concept comes up, like
sorry, doctor,
yes.
I have a question with the previous example. Sorry.
Okay.
Maybe I can interrupt you. In the test and the main function, we have a return value of integer. When you pass a variable by value, what will happen if you return the value from the test function and the main one? Shall we get 5 or 6 right now? For example, in the previous example that we have made.
I'm actually struggling. Sorry, I'm struggling to hear exactly what you are saying. So kindly slow down for me. Let me try and get this, okay? You asking if we pass an integer value. Is that what you said? To the function.
Yes. Yes. What I'm trying to say is, in the previous example, on the test function, when you pass an integer by value, and you if you have a return value of it, the main function, what will you get in the main function?
Oh, okay. If you have a return value to the function.
Yeah. Yeah.
Okay.
Is it the same?
Okay. So what we need to know is when it comes to returning something by a function, you decide what you want to return. Okay, you decide what you want to return. So in the example that I did here, I ended up not returning anything from this function. Okay, I could have decided to return the value of A, but all that it would mean in our case is that, hey, just return the value, like the exact value. So if A is 6, all that this function is doing is anytime you call this function, it's going to give you 6. It doesn't have anything to do with the variables you have in there. No, not at all. That is why I didn't bother returning anything. Okay, so the return is intentional. Like I could, even after I've done this, I could have said, okay, return 267. I could have done that. The return is used when you are going to call this function. So if I was using a return value, I would have to reassign maybe A to the return value here before I'll be able to get it. Okay. If you run a function, this thing I think I was supposed to explain it earlier and it escaped me. If you run a function, there are two things. The return value is very important actually. Like when we start building bigger projects, you realize the importance of return. You are intentional about what you return. What do I mean by that? What you return, you decide that, okay, I want this function to return something like this. So for instance, if you write a sum function, you want your function to return a sum. You decide that, okay, this function should return this and that. But for the return value, until you print it out, it's not going to show to the screen. That's the difference. If you create a function test, or let's create a function, and assuming we've defined this function to add 2 integers. So whenever I call this is going to give us 7, but it's not going to print 7. It's if the function, maybe I should do an example. Open this. Please pay attention to this particular question, okay? We need to understand it. So let's create a function here called sum that is going to return an integer, takes in 2 integers, say x and y. Then we are going to just add x and y, and we are returning the value x plus y. That is what we want to return. Okay, so let me put the prototype here. This thing. I hope you can see the way it is. Okay, so let me just clear up the spaces. So now we need to call the function we've created. Sorry, we need to call the function we've created in here. If I just go ahead and call, say, 3 and 4, when I run this program, nothing is going to happen. Okay, all that is happening here right now is that this function has actually done the summation and the value is 7, but we haven't assigned that value to anything else, so it doesn't do it. However, if I have printed something, assuming I didn't return and I rather printed, print f of, then I'll say %d of n, comma, say x plus y. Let's see the difference. Now let's even assume I didn't return anything. When we run it, this gives us the value, because by the time this function, so let's see how C will read this. C starts from the top, or the compiler starts from the top, tries to do the processing here, the pre-processing and everything, finally gets into the main function, then finds this. Okay, sum. Immediately it finds this. Already from the pre-processing of the header files, it knows that there is a prototype here that it needs to know. So anywhere it sees sum, it takes this format, and there is a function that is like that. So the program will automatically jump from here and go look for where the function is. So it will jump down here and see that, okay, there is a function here, definition here. It just takes X and Y. Then the next task is print this. So it's going to print it for you. If you return those two values, it's not the same as when you printed it. So we'll realize that most of the time when we are creating functions, we actually do not print within the function. When we are doing more practical things, you want your function to return a particular outcome. So in this particular case, I would want my function to return. Then anywhere I want it, maybe I create a new variable called integer x, and I pass it to this. Because this function returns 7, it means that if I go ahead and I print f of say %d and x, this should print out 7 for me. Great. It's only because this function is returning 7. If I come here and maybe I do, let's say, x plus y in here, something like that, then I do return, say, 20, and go ahead and run this program, it's printing out 20. The reason is that even though there was an addition here, that is not what we returned. What we returned was 20. So anywhere you put any two variables, you are saying it should return 20. So that is exactly what it's going to return. If it wasn't, if I change this to, let's say, 8 and I run it, it's still going to be 20 because I'm telling it to return 20. But the moment I change this to x plus y, it's going to return the addition of these two. And if I change them 7, it's going to give me the right value. So what is happening here is that if you say return value, that is, you decide that, okay, this function that I've created, anywhere that I reuse the function, what value do I want to give to whatever I'm assigning it to? Okay, so note that we create functions to help us do like the bigger code that, or the bigger program that we want to have. We'll create functions to solve simple problems. For instance, if you've been tasked to create, let's say, a school management application, maybe in that school management application, you need to be able to calculate the school fees of the people, how much they owe, their academic performance sum, find the sum of the scores that the person got, the average. So you create simple functions. One function called maybe average, and that function you only call it when you want to calculate average. So you decide exactly what is going to return. Okay, so right now we are using more of the print because they want us to see exactly what we are doing. But when you are doing more of the product itself or the program itself, you are going to be using the return, like the most times you are going to return. And it's very unlikely to be returning 0, 0, 0, 0. Just because we are now in demonstration purposes trying to understand, that's why we keep returning 0. But the important thing is that your function, unless if that function is not supposed to return anything. So sometimes we have functions like that, they are not supposed to return anything. You want them to just go and do, okay, for instance, the pointer. Let's just use this function to change something in the memory. That's all the function is doing. It doesn't have to return something to us. So that's why when I created test, I didn't return anything. All I was using test to do was to change something in the memory of the computer. I hope that makes sense. So we should know the difference between when we are printing out something and when we are returning something. When you are returning something, you decide what to return. And what you return, you can reuse. Once you return that, you can reuse it. In fact, I think yesterday night I wrote an article on one of the quiz questions that we had yesterday. And in that case, I tried to explain the return values because you needed to know the return value of the functions. There was a print statement and there was a return value. So you needed to differentiate what a print statement was, or what it was going to print and what it was going to return, which are two different things. Okay. So if you're not too clear on it, maybe you'd want to read that particular article. I think I've already shared the link in the Telegram group, so you can check it out and then see, like, get some better understanding. Any other questions on that? Otherwise, we are behind time with our Aries. Okay. Yes. All right. We can go on, hopefully. So I've explained. Do you have a question? Yes.
No, not a question. Just a reminder.
Okay.
I hope you're recording.
Yes, please. I hope I am doing too. Yes, we have recorded 1 hour already. Yes, please. I've recorded. The past mistake shouldn't repeat itself again. So I'm very cautious now. All right. Aries. We've talked about Aries, and okay, I was saying something before the question came, and what I was saying was that all these concepts that we are dealing with, okay, anytime you start a new concept, ask yourself, why this concept? What is it? When should it be used? When can it not be used? At least get answers to these 4 questions. What is it? So what are Aries? When can I use Aries? When shouldn't I use Aries? Why do we use Aries? Just get the concept. Like, once you have answers to these 4 questions, it means you now understand the concept. Then you now see the practical application of it. So that's what we did in the previous last 2 sessions when we talked about the theory regards to Aries. So we explained all of that. I don't want to go there. I want to do more practical today. So hopefully, if you are here and you haven't watched it, you can just go back and watch it when you get time. But today, let's go directly into Aries. So in simple terms, Aries is just a collection of variables. Okay, so we all know by now how to declare variable. If I want an integer variable called v, I can do something like this. Okay, but we have a case where, let's say, we need to have like the result of 100 students. If all we know is variables, then it means we are going to declare v1, v2, v3, v4, v5 up to v100. We are going to declare 100 variables. What if there are thousands of them? We'd have to declare that plenty variables, and working with them is not going to be easy. Therefore, there is a new concept that we are learning. Instead of declaring plenty variables, we can actually have just one variable, but put together all of them. So we'll have, if the marks are 80, 90, 100, 72, we can have all of them put together in just one variable. And that is where the concept of array comes in. So a collection of variables of the same type is known as an array. And I keep saying this during almost every session, that the concepts we are learning are actually just a build-up of the previous things we've learned. So now you all know what variables are. Instead of declaring just individual variables like that, there are some cases where it becomes practical to put a set of variables together. But for arrays, before you can use them, that set of variables have to be of the same data type, and talk extensively about data types. So in our case, if it is integer, all the values that we put here should be integers. So far as we can put several integers together and assign it to just one variable, that particular variable is no longer referred to as a variable but as an array. The reason is that it's an array because it contains multiple values of the same data type. So I've explained what arrays are, and now we can move on. Practically, we want to see, how do I declare an how do I declare an array? Okay, so that's the first thing we want to look at, how to declare an array. And we would have noticed a pattern that in C, almost anything at all that we learn that we want to use, we first have to declare it. And when we are declaring all of these things, there is one peculiar thing, the data type. Almost everything that you've learned so far that we say you declare, you always tell us the data type. Very important. So for our arrays too, we need to tell our computer the kind of data that the array is going to accept. So we start by telling it the data type. Data type. It is the same as we did here. So when we were declaring a variable, we told our computer the data type, then the name of the variable. Okay, so it's not any different. When we come to arrays, we tell you the data type is going to contain the name of array. The only difference is that, unlike the name of the variable, we have to differentiate this by putting a square bracket in front of it. So that square bracket you put in front of it is just telling us that, okay, this is a variable that contains multiple things. That is all. That is all the square bracket is doing. It's telling your computer that, okay, I'm going to declare a variable, but this variable contains multiple things. And we have decided that anytime we have a variable that contains multiple things, we call it arrays. But specifically multiple things of the same type. So if it is integer, just int. So going forward, we will learn about what collection of multiple things of different data types. Okay, because that is also something that you may meet practically. When we get there, we'll talk about it. But now let's focus on collection of multiple things of the same type. We put them together and we call them array. So this is how we declare an array. Once your computer sees something like this, it knows that you have declared an array. But the other thing that may be necessary when declaring an array is that you have to explicitly tell your computer how much space should allocate for your array. Ideally, if you are working with a variable, you don't tell it because it's just one integer. And your computer knows, for instance, in this our case, or for the purposes of our discussion, your computer knows that each integer will take out just 4 bytes of space. So it will automatically make room for that 4 bytes for the variable that you have declared. But when you are going to deal with arrays, the unfortunate thing is that you are telling it maybe your data type is integer. So you are telling that you're going to give it a number of integers. Before you even go ahead and give it those number of integers, the computer has to make room, has to make a reservation for you. So how many rooms should I leave? It's like calling a hotel and saying, hey, I'm coming to the hotel with my entourage. How many rooms should we leave for you? Okay, so the variable is like going to the hotel by yourself. When you call, oh, I'm the only one coming, they know that, oh, you are a single person, not married, you need just this room, maybe a standard room. But the moment you say, hey, I'm coming with my family, the question now becomes, how many are you? So that we know the exact number of rooms that we should reserve for you. At least we would also need to know the type of data that you are carrying. So, oh, I'm coming with my squad. We are all boys. And we know that, oh, for boys, maybe we can give them one room, or we can pair them up. So let's reserve this number of rooms. This is exactly what we do when we are declaring arrays. Your computer knows that, okay, you are bringing characters. For each character, I'm supposed to reserve 1 byte. So the question is, how many characters are you bringing? You have to state that here. So this n that I've written here, we call it the size of the array. Sorry. I mean, the computer will calculate the size of the array. Yes, okay, it's also called the size of the array, but the n represents the number of elements. Yes, it's also called the size of the array, but the n represents the number of elements that your array is going to have. Okay, because obviously the size can be calculated based on that n. All right, but it's representing the number of elements the array is going to have. So let's get to our compiler and say we have an integer array. I like using integers, don't blame me so much. Then let's assume that we have the name of an array called scores to put or take the scores of some students. So what I've done here is to tell my computer that, oh, I'm going to be passing a number of integers to this specific variable. The question that this computer is going to ask me is, how much space should I leave for your integers? That means, how many integers are you expecting? So you would have to go ahead and tell explicitly that maybe 5 integers. Okay, so this is how you declare an array in C. Tell it the data type, give it a name, tell it that it's going to be a collection of data by introducing the square bracket. Then inside the square bracket, tell us how many elements you are going to put in there. So that is declaration. If I was supposed to declare, let's say, test1 as a variable, this is how I would have declared it. Let's pay attention to the difference. I would have declared it without a square bracket, obviously. That we know for now. But we also know that I could have done what we call initializing the the variable. I could initialize the variable, or I could declare and assign a value to that variable. In the same way, we can do same to scores. So let's say with test one, the person scored 20. If the person scored 20, I can now come here and say test is equal to 20, and my computer will understand. Sorry, test one, I meant. But the other way would have been for me to put them together, say test one is equal to 20. In the same way, after declaring this, I can go ahead and now assign values to scores. So we are now looking at, we've looked at the declaration. I'll talk about another type of declaration, but we are looking at initializing the array, passing values to the array. Okay, so there are several ways that we can pass values to the array. We can pass values to an array when we know it. Like right now, maybe I have these test scores from memory and I'm going to put it there. So I know it. I'm going to put it there. If you know your values up front and you're going to give it to your computer or your program outright, okay, it means that values or those set of values will be available to your computer when it is compiling the program. Okay, so there are, when it comes to array declaration and initialization, some books or reference materials that you use will talk about the compile time initialization and the runtime initialization. So I'm just trying to explain those two concepts so that when you see it anywhere, it doesn't look anything different or new or scary. When I go ahead and say do something like this, okay, I know that this is supposed to contain 5 integers, and this is the syntax. So we use the curly brackets to indicate the values within an array. So I'll just go ahead and put the values. Maybe 85 was the first, separated by commas. 78 was the second, 92 third, 84, then 65. Okay, so these are the 5 values. So I could have done this, and this that I've done is no different from how we used to declare the variables. Very similar concept, except that here we told it that this special variable known as an array will have 5 values. So these are the 5 values: 1, 2, 3, 4, 5. Fair enough. When I have done this, this means that when the compiler compiles the program, it's already aware of the members of my array that I've declared. So this can be termed as compile time declaration. Okay, compile time declaration. There are times that I don't have the values to this program, so I'll just declare it like I did initially, something like this. Then when we are running a program, I want the user to enter their own value. So assuming I'm going to use scanf to collect the values that a person is going to enter into this array with the help of a loop. If I'm going to do something like that, then it means that during compile time, I have not initialized this array. Okay, it is only when we are running the program, so that becomes runtime initialization of array. So those are two concepts. Like, it's not something that you need to know like that, but I mean, you may come across it when you are reading or learning about these concepts, and you need to understand it. That's why I'm mentioning them. But all that is important is you should know how arrays are declared and how they are assigned values. So I could have just gone ahead and do this. Also, C allows us to go ahead and declare without telling the computer the exact size, only if. So here it's going to be permissible, like we are allowed to do this, but on one condition, only if we give these values. So let's provide the values, or let's assign it. If you are going to assign it to the values, then you can go without telling it the size. So the computer will calculate it by itself. Sorry. The computer will calculate the size or the number of elements and automatically insert it in its memory that, okay, the size of this array is this. Okay, so this is equally acceptable. This is equally acceptable. However, this is unacceptable. Line 6 right now is unacceptable. You can declare an array without telling it the size when you haven't initialized it. Please let's pay attention. If I do this, line 6 is acceptable. Why? Let's try and understand why. After I have done this, I've told my computer that, okay, I need you to reserve enough space for 5 integers. Each integer is 4 bytes. So your computer is going to reserve, your computer is going to reserve 20 bytes. Okay? Because you've already told it, these are integers that I'm going to store in these arrays, and there are 5 of them. So 5 times 4 is 20. The computer is going to reserve 20 bytes. So anytime that you want, you can then bring the members of the array. But if you happen not to give us the size here, the computer doesn't know how much space it should leave. So that is the problem. It will only permit you if you decide to assign the values, so that now it will automatically find, okay, there are 1, 2, 3, 4, 5. There are 5 elements. For that matter, I should leave 20 bytes of space. Any questions on declaration and assigning values to arrays? Any questions on that? So there are times that you may want users to enter their values, as I talked about earlier, saying it's called runtime assignment. In those specific cases, you would have to take away this and suggest probably a size. And usually people would want to even give huge size so that it makes room for whatever values the person is going to enter. But sometimes you also want to restrict your users. Maybe you are asking them to just input 10 digits, or let's say input 3 digits. I know that I'm going to ask you to input 3 digits, so I can say my array is going to take 3 or size 3. Okay, please pardon me if you see that I'm repeating. I'm just using it to explain. Okay, so it doesn't mean you can use the same name like that. All right. So this is acceptable, as well as this is also acceptable, and those are how we declare arrays, or we assign values to arrays. Now the next important thing is, how do we access the values of these arrays? If I've assigned this, okay, how do I get these members? So for those of you who didn't join us for the last discussion on arrays, we mentioned that there are two terminologies that you need to understand when you are talking about arrays. There are two terms you need to understand when we are talking about arrays. They are, so when we mention arrays, you need to know what elements are. So if I say elements of the array, then you need to know what index or indices of the array are. The same elements can, is someone talking? Okay. Elements are also known as members. So you can say members of the array or elements of the array. Then index. So for us having the scores array, I don't remember the values and I don't want to go back. So let me just forge some values here. Okay, so when we take each of these, they are members. Each of them is a member. Okay, so this is the first member or first element. This is the second member or second element. This is the third member or third element, fourth and fifth, in that order. Those are referred to as members. But practically, we'll be using more of the index. The only difference between the elements and the index is that with index, we start counting as 0. And if you are part of ALX up to this point, I believe that you should see or realize that almost everything we do starts with 0. So that's why you always have tag 0. We start counting from 0. And in programming, almost all the time, especially when you are dealing with arrays, and you are going to be meeting them very often. So you should get used to starting to count from 0. So 0 is a count. You should start getting used to it. And that is index 0, index 1, index 2, index 3, index 4. Okay, so the index is what we are going to use to access the elements, not the elements or the members. We are rather going to be sticking to the index. So please pay attention to it. It is what confuses a lot of beginners. So let's pay close attention to it. It always starts from 0. Always. You may tend to forget it most times, but always remember when you are debugging your code, especially if it is an array, just prompt yourself that, hey, I'm using index. I have to start counting from 0. Mostly when you're having issues with your array, especially when you expected it to print something, it's printing something else, it's likely you are using the wrong index. So always pay attention to that. Okay. So how do we access it? To access any of these elements, assuming I want to access the second element, which is index 1, I'll call the name of the array, then pass the index as a subscript, and this is how we write it. So by writing scores 1, all that I'm saying is that go into the array scores and look for index 1. So it goes here and says this is index 1, and it print. Let's say if we are printing the value, it will print value 80 for us. So that is how we access the values. If I want the last one in this case, then I should be printing scores 4 and not 5. Pay attention, scores 4 and not 5. I'll come back to explain something, but for now, at least, let's understand that. So let's see. I want to print something. Print f of %d, and let me pass scores 3. Yeah, someone should unmute and tell us what are we going to print to our screen right now. What do we expect to print to the screen?
84.
84. Okay, so on face value, you would have thought that, oh, this is 3, so you go with this one. But no, you have to start counting 0, 1, 2, and this is 3. Great. So let's go ahead and run it. 84. If we change this to say 1, yes, what do we expect? 78. So let's pay attention that 1 is not this, but rather 78, because we start with 0 and 1. So run this 78. So basically, that is how we assess the members of an array with the help of the index. Now, we've been working with pointers. We've been trying to explain the logic behind pointers, how to practically use pointers, and the rest. This is where they become like really useful. So using index to access members of an array is just one way. We could equally use pointers to access them. And that was actually the main reason why we spent a lot of time on pointers alone before jumping here, so that we could bridge through it. And hopefully by now you know pointers and you understand them very well. So let me just go back and explain something here. Sorry, then we can move on. When you take an array like this, okay, so let's create, we are still working with our array called scores, having 5 members. And say 90, 80, 70, 92, 81. Okay, so this is the array that we are dealing with. Okay, obviously these are integers. What you need to know about arrays is that just the array that we have, okay, the concept of array is a bit similar to pointers. The interesting thing is that whenever you call the name of just the array like this, if I say scores right now, scores in itself is a pointer. Let's understand that. Sometimes you don't need to battle to understand things, okay? Like some of the concepts, this is what they are. I keep saying, when we were in primary school, they taught us, or nursery or kindergarten, they taught us 1 + 1 is equal to 2. If you and I have not argued it till now, everywhere we see 1 + 1, we say it is 2. Okay, so this is one of those kind of concepts that this is what it is. So just keep it in your head. When you call, after you have declared an array, whenever you call just the name of the array, it points directly to the address of the member, the first member, address of first member. What is the index for the first member? What's the index for the first member?
0.
0. So that means that address of index 0. So whatever the array name is, index 0 of it. When you just call the name of the array, the name of the array represents a pointer to address 0, the address of index 0 or the first member. It has practical use, and it's actually leading us to answer the question that we were asked about strings. I've forgotten who asked. I should have kept the name that I told you to remind me when I start talking about arrays. That is what is happening here. Remember, also, when you call this just the name, when you call just the name, you are pointing to the address. So this in itself is more like a pointer. What does it point to? The address of the first member. And now you and I know that, for instance, these are integers. Okay, and for each integer, your computer reserves how many? 4 bytes of space. For the purpose of our discussion, it could be 2 bytes, but for the purpose of our discussion, your computer reserves 4 bytes of space. If your computer is reserving 4 bytes of space, and you know the address of the first member, how can you get the address of the second member? Question 2. you all. Now we know by calling this, it gives us address of the first. Yes. How do we get the second?
You add 4 bytes to the address of the first number.
Okay, good. So all we'll need to do, since these are integers, and remember, arrays are stored as in a continuous form or contiguous memory location. Okay, so in your computer's memory, an array will always be stored in the order in which the values were declared. So if this is the memory of the computer, we can have 90 here, 80 here, 70 here, 92 here, 81 here. Please, if this look a bit some way and you don't understand, you just have to take time and go back to our previous lesson where we took time to explain all of these concepts. Okay, today we are just focusing on the practical aspects. So we are saying that by calling the name here, scores, is pointing us in this direction. So we now know the address of this. Each of these bars is actually an integer, so we know that it's 4 byte space. Each of them is 4 bytes. So for instance, if I am here and I want to move here, I have to just add 4 bytes. That is all. To get the value in the next location, add 4 bytes, which is an integer. The next one, the next one, 4 bytes. This means that by just knowing this or having the name of the array, I can access each member in there using their addresses. Do you understand? So if I go on and I do something like this, scores plus plus. Those of you who were here last time, scores plus plus. What does it mean? Scores plus plus. What does it mean?
Just post increment.
It means
Yeah.
I don't want to the scores.
Okay, great. Thank you. We are going to add 1 to the scores. But does this make sense? What does scores represent? What does scores represent?
The first element.
Right, sorry, I didn't hear.
The first element, that means we're adding 1 to the first element in the array scores.
So if the element was 90, are we adding 1 to 90?
Yes.
Adding 1 to the address.
Okay, good. So let's pay attention that I said that the name scores points to the address. Like it's a pointer, it's not the value. It's a pointer to the address. Okay, so it's not 90 that we are adding the 1 to, but rather the address that we are going to add 1 to. And when you do 1 plus an address, and you know that this is integers that we are dealing with, and you know this 1 is actually adding how many bytes? How many bytes is it adding? Good, 4 bytes. So just by doing scores plus plus, that's fine. Just by doing scores plus plus, we are adding 4 bytes to the address that scores was representing. This means that we are moving to the next memory location and getting what was there. Okay, so if I dereference the new value of scores, then I'll get the next value. This is why pointers were important.
Sorry. In a case that you have not pointed the element to or the index to a pointer variable, can you the address like that?
Yes. So as soon as you call and like you create an array, as soon as you create an array, the name of the array is a pointer to the first index. So you don't have to go and declare that there is a pointer. Okay. So basically, do you know what's happening? Let's see it from this angle. if it was an integer, let's say if scores was just a variable that we created, what would have happened? And say scores is equal to 2. We'd have to get the address of 2, right? Sorry, the address of scores. So that we would have used ampersand to get the address of scores. Okay, I hope you understand this. When you get this address, you know that wherever the computer is storing to, if I want to put something next to it, all I have to do is what? Add 4 to it. I mean 4 bytes to it. Then I'll put the thing in here. If I want another one, I'll add 4 bytes. Then it's like that. Then I'll add 4 bytes. And it's like that. So that is how we're able to come up with the concept of arrays. That's how we're able to come up with the concept of arrays. All we needed was, oh, okay, what is the address of this our variable? We need to put something adjacent it. We don't want to go and keep, because if we declare them as ordinary variables, our computer will know them about. It will choose wherever to put them. But we need them to be in that order, so that anytime we are putting them, we know that one comes after the other. So to help us do that, this is what we do. We get the address of the first one, then we increment them by a specific size, depending on the data type we are putting in there. So because of that, a new concept called arrays was developed. And we are saying that this is what we call the array. But instead of going to declare an address, if you just mention the name for it, just the name without this, please pay attention. I keep saying just the name. It means the square bracket is not part. As soon as you call just the name without the square bracket, what you have done is that you're calling the pointer to the first member. Okay, that's the pointer to the first member. So you are just pointing to the address where the first member is. This means that if I go ahead and I dereference, just dereference that scores, assuming we have this array. Oh, where is our array? Okay, let's use this array. If I dereference scores, what will I get? Someone should help me. What value am I going to print out if I dereference scores?
90.
90. Because we know that scores on its own is a pointer to this. So it's one of the reasons why we learned about pointers. If you didn't learn about pointers before learning about arrays, you will understand this. So now we've learned that there are things we call pointers. But when you are doing arrays, you don't necessarily go and even tell your computer that you are creating a pointer, because the name of the array itself is a pointer. The name of the array is a pointer. Without the square bracket, the name of the array is a pointer. If you decide that you are going to use the square bracket, so if I'm going to use, say, square bracket A, then look for the second element, or index 2, sorry, index 2. If I want the address and not the value, because this will give me the value. If I want the address, then I have to append the ampersand sign for it before I get the address.
But no, you still find the second index.
If you append the address, you are looking for, if you append address of, you are looking for the address of the second index. So it will come here, 0, 1, 2. It will give you the address of this member, not the value. If you want the value, it's just scores and index 2. If you want the address, you append the address of to this. Okay, but if you don't want to go through any of these stress, just use the name scores. You know that this is a pointer on its own and it points to index 0. So if I do scores plus 1, you know that I'm moving to the next one. If I do scores plus 2, I'm moving 2 times. So I can do scores plus 2, and that address will be the same as address of index 2.
Sorry, 1 minute. It says that you can point a pointer to a pointer with double asterisk. So in a situation where you want to point an array to a pointer, do you have to use double asterisk or one single asterisk?
That's quite interesting. I haven't even thought about it, but just as I'm saying, if you are using just the name of this, just the name of the, how do you call it, the array, then you wouldn't need a double. So just by doing one asterisk scores, then it's like a pointer to scores. So unlike pointer to pointer where we do double, like we do something like this, PTA, like that, if it is the scores, you should know that it has catered for this because it is an array. So you wouldn't use the double. Do you get it? So let's do practicals to illustrate it. Now we want to access the addresses. So you and I know that for us to get, let's say, address, I'm saying that if we print P, if we print P, okay, so let me write something. Address of index 0. Okay. I can just call scores. That's what we've learned so far. Okay. That, oh, if I want the address of index 0, I can just call scores. And it's printing it for me. How can we prove that this is true? Let's prove it by using what we already know. We know that if we want to find the address of index 0, we actually should get address of that value. To get the value of at index 0, it is scores then the index in the square bracket. So if you go ahead and print scores in the index of the square bracket, like what we did here, let me first of all print this. I want us to appreciate everything. So trying my best to explain everything. Sorry. If I print this, I print 78, which is index 1. Sorry, let me change to index 0. So 85, as we can see, this is 85. So if we want to find the address of this, we know that scores of 0 represent 85. So we can append an address of sign, which is the ampersand symbol, to it, and we are going to end up with the address. So hopefully this line and this line should print the same thing. So let me say A and say B here. Hopefully they should give us the same results. Can you see? I hope you can see that they are the same. So instead of going through the stress of coming to write ampersand and this and square bracket before the 0, just quote the name of the array. They are the same things. They are the same things. If I want address of index 1, it will be the same as this pointer plus 1. So run it and they should give us the same thing. If I want address of index 2, in the same way, scores plus 2 will give us that. Now that we have the address, say we know that these two, so let me revert to scores and revert this to 0. If I want to use, with the help of the pointer, to get the actual value in the array, because that's what we are driving at right now. We are looking at accessing members of the array through pointers. I have to dereference the pointer, and I've told you that this is a pointer. Okay, so if I want the value, say the value. Oh, okay. Let me not delete this. Let me just copy them, then comment this out. So now we are interested in the values. We want to see if both of them will print the same values. So values of this, change this to decimal. The same here should be value of. Okay, so this, as for accessing with the index, we've already done that. So we know that this will print out the value for us. But this, we've already said, is the pointer. So we have to dereference this pointer. How do we dereference this pointer? Just put an asterisk before it and run this. And you can see that we are printing out 8585. So just by dereferencing this, you are getting the value. So this answers the question that I was asked initially, that when we are working with strings, why don't we use the ampersand symbol with these ones? Okay, the answer is simple. The string is an array of characters. So the name that you have given to that string is actually a pointer to the first member of that string. Therefore, you can just call the name, and once you call the name, it's a pointer. You can do all the operations, addition, increment, all of them. You can do it on that pointer, and you should always remember that you are dealing with the address. The same way that you work with every other pointer, you can work with it like that. So now we have the value, access to the value stored in that particular pointer, and this means that we can work with it anyhow we want. Any questions on that? Any questions on that?
Second member.
I can't hear you, sorry.
Can we call it by differencing the scores and hello, can you hear me?
Yeah, I can hear you now. Yes, I can hear you.
Hello? Okay, I said how do we call the second member?
Goodness, I can hear you.
How do we call the second member?
How do you call the second member?
Yes, the way you difference the scores with asterisks. How do we call the second member? Do we have to add one?
Okay. Yeah, so that's what the question I was coming to put across, so that some bring your suggestions before I talk about it. Now you know that this scores points to what the first member or index 0. Okay, and when we dereference it, we get the value at index 0. So if I want the value at, say, index 1, what do you think I'll do? Value at index 1. Someone should just unmute and tell us. What will I do?
Since in the second printf you printed a value in the index 0, so you can just change that 0 to a different index. And
okay, we are interested in using just the scores, not the index. Okay, so how will I make this equal to this? How will I make this line right now equal to this line?
Add plus after the asterisk.
Come again.
Add plus the increment sign after the asterisk.
Okay, so I can add plus. In order not to get confused.
That will increment the value.
Yes, so we want to, that will increment the So in order not to confuse ourselves right now, because last time, the last part that I did, I realized that even though what we did was right, when I went back to read on the precedents and things, they are a bit different. Okay, so for now, I use this, and because we don't have enough time, what I'm thinking is that I will do a separate video, probably a shorter video, not the thing like this, just a shorter video explaining the precedence of the operators, okay, so that we all understand. But for now, let's just do it as +1, but this would be in this form for it to be correct. I hope you get why. if you do not bring this, what you are doing is that you are dereferencing scores and you are adding one to the dereferenced value. Okay, so what we intend to do is to add one to scores before we dereference it. And I hope by now people, like, you understand those terms, dereference and things. I mean, scores is a pointer. That means that it holds an address. So if you add one to scores directly, it means you're adding, in this case, because it's direct, you're adding 4 bytes to that address. Okay, but if you do not do that and you have the dereference score, this is going to pick the exact value. Maybe we just try. Go ahead and print. So we see difference. This is picking a value at scores because we dereference scores. Scores is 85. So after you dereference it, we are getting 85 plus 1, which is 86. But if you bring the brackets here, what we are trying to do is that this address, add 4 bytes to it. That's plus 1. We know that by now. Adding 4 bytes to it. So it means from wherever we started, as pointer of index 0, move 4 bytes, which is go to the next element, so 78. So this will have to print out 78. Okay, so hopefully I'll try and make a separate video on the operator precedence so that we understand how they apply. But this is how you get it. So to goodness question, if you want index 2, then we are going to do scores plus 2 in here, which should be the same as printing index 2 here. Any other question? Any other question? I think I'm not feeling fine. Any other question? I'm trying to get a code that I don't want. Huh. All right.
Sorry.
All right. Yeah, thank you. So let's see. Quickly, the time we have an AMA session at 1, so I wouldn't want to even go past 12:30 so that you can rest before that time. Let's quickly talk about strings. Then we can conclude on the matter. For now, all you should remember is that unlike other programming languages, strings are arrays of characters. When you go to other programming languages, they have created string as a data type. They have created string as a data type. So you wouldn't need to worry about all of these things. A string is a string. Like, it's just a sequence of text or letters or however, alphabets or however you call it. Those will be recognized. But in C, we don't have strings. So string is derived, just like arrays are derived. But strings are just arrays of characters. So when you put certain number of characters together, you form a string. That is all it means. And everything we've learned about arrays right now applies to strings. This means that if, okay, let me not jump. Let's look at how you declare a string. So to declare a string is similar to how we declare what characters, or I mean arrays, how we declare arrays, but the data type is a character. So we learned that to declare an array, you need a data type, you need a name of the array with a square bracket and the total number of elements. So say 5, or let me put n here. We need this to declare. This means that to declare a string too, we need to say this is a character, then the name of the string. So say what name? Okay, so let's say name. That's the name of our string, name, and this name holds say 5 characters. this makes name a string. It makes name a string. So it's just like an array that we declared, but this makes name a string. And from the declaration of arrays, we learned that we can easily go ahead and assign this array to some value. So we could go ahead and say that this is equal to O. Sorry. Since they are characters, you don't have to forget your to put them in the quotation marks or whatever they call them. Okay, so O, B, E, and D. This concept you should always remember wherever you are dealing with characters. In fact, in other languages, when you are dealing with strings, you always should remember to put them in the brackets or sometimes even double quotes. Okay, so let's remember this. So by doing this, I've declared an array of characters, and this is the string. If I go ahead and print this particular array as a string, so if I do print of this and I use format specifier to be a string, it's going to print my name Obed. So strings are no different from arrays, except that there is another way that we can declare this. Instead of writing name bracket 5 like this, we could actually do star, then still pass it like that. Let me go to the next board. So all we've done is that we are creating a string called name that will hold my name. Then we are saying that it should contain, say, 5 elements. And we have assigned this to O, B, E, D. Okay, that's what we have done. Then I'm saying, just as we learned earlier, we could do the initialization without telling it the size. Then put exactly what we have here. Okay, so this is just a repeat of what you have here. The other way that we can declare a string is just by saying this. Then instead of using this notation, we'll rather go ahead and put it here and say Obed. That is acceptable when we are working with strings. That's acceptable when we are working with strings, okay? So let's take note of that. So this is one of the other ways that we can declare a string. The computer will automatically estimate the number. You can still go ahead and put the number that you want here, okay? But one interesting thing that we need to know that makes string kind of special when we are dealing with C is that the string, the computer will always append what we call the null character at the end of the string. So far as it is a string, the computer will always append the null character. And this one, we are going to demonstrate it for you to see why it's important that we append the null character. If you are printing out a string that has no null character, your computer will print it and print other things in the memory because it didn't see the null character. It will print until it finds a null character. Jesus, sorry.
Okay. Doc.
So yes, how you are about to answer that?
In this example, a chart string, you declare the elements to be 5, but inside it, the object there are 4 distance. How it?
Okay. I actually didn't pay attention to that. Okay, so that isn't really a problem. It isn't really a problem. And what you need to write is exactly what you want to put in there before. If you write more than that, the only thing is that the computer is going to just assign that value. So I mean that space. So the space will be empty over there. We'll be expecting to have something, but if there is nothing, so it wouldn't give you a problem. But at least what you can do is that if it is 4, you can't write 3. If you write 3, there will be a problem. Okay, if it is 4. That means you are reserving space for only 3 characters. You are actually saving 4 characters, which is not possible. But if you make this is 6 and you save only 4, that is allowed. Okay. All right. So what we need to pay attention about strings is the null character. So that is what makes strings special. They are arrays, but the computer will automatically apply a null character, and the null character is just 0. Okay, so you do something like this. So the computer will automatically append this to the end of your string. Let's try it out. Sorry. Okay. So let's try creating character name for is equal to Obed. Print f of percent string. So this is the format specifier that we use x. Then okay. So if we go ahead and run this, it gives us the value. I was thinking someone will ask a question here. Yes. Does anyone have a question about this? Yes.
So in the when we're looking at the int, when you want to print, let's say, first integer, you have to include the distance there. So here, were you not supposed to add the 4 with the name?
When I'm printing?
Yeah.
If I put 4 in here, what have I done? What does this mean?
Means you are printing Obed.
No.
I think you are printing the null byte, I think.
Okay. So
you did not include the null byte in this one. Is it not necessary that you put the null byte?
I'm coming. Let me run this. Okay.
If you
okay.
put
So
4, that means you're printing the
I think it has to be 5.
fourth
So
element.
That relax. I'm coming in. I want to confirm something. No, I don't think the null bytes comes in. Let's see. Let me run this. No. Okay. Oh, okay. I get why I was getting the negative. So when you are printing it in here, you are printing the index. So the 4th index. This is index 0, index 1, index 2, index 3. So index 4 is the null. Okay. But to answer Harina's question, Harina, the moment you do this square bracket and you put the number inside, you are accessing a specific index. For the string, that's what it means. If you put the value in there without this, I'm calling the string. So it goes in there to that specific address and print out everything up to the end. Because I said a string, please let's pay attention here. That's why the string has the null character. Okay. All right. So we need to finish soon. I think I'm not finished. name. So I'm trying to print name, okay? And you are doing string, you are saying string print name. What have we said about this? When you call this, what have we said about it?
I think you are printing the first character.
Print the first character.
Explain it well. What does, okay, we are not printing. When I say this, just name, what does it mean?
I mean,
Means
you are
that's the first index.
Okay, so the address is what I want you to mention is that this is a pointer. It's a pointer, so it gives us the address to the first index, or sorry, index 0. I mean, first member. Okay, so when you go and print print this, okay, what actually happens is that the computer is going to this specific index location. When it gets to that location, we have O there, but because you've told it it is a string, the computer is going to print everything after it until it meets a null character. That is the reason why your computer automatically appends the null character to it. So as soon as it meets a null character, your computer will break there. Do you understand? So name points to what? It is pointing to, let me write the thing again. The actual array that I created was OB. But if I call just name, I'm going to print out just name. What is actually pointing to is just this. The value here is what I'm supposed to go and print. Okay, but because I said I am printing a string, I use %s to say that I'm printing a string. Once I've told my computer that I want to print a string, it goes to the address that I've passed to it. So it just takes the address. This was the address. It goes there and see what is there. Is it a null string? No. If it is not, print it. The next one, is it a null string? No. If it is not, print it. The next one, is it a null string? No. If it is not, print it. The next one, is it a null string? No. If it is not, print it. The next one, is it a null string? Yes. End. That is how the string works. So I told you that a string is not default. String is actually derived. Like C programming doesn't by itself have strings. So it's derived. Yes.
I can't hear
yes,
you. I'm trying to know if I can hear you. Is it from my
Come again. What are you saying? I can't hear you. Sorry, I didn't hear what you said. So what I've said so far is that when you pass just the name of the string, it's an address. There's an address. But because you use a percent specifier to the format specifier to be a string, your computer goes to that specific location to look for what is there. Then he sees whatever is there, it checks, is it a null value? He says, no, it's not a null value. So print this. Is this a null value? No, print it. Is this a null value? No. Let me try. I hope this will explain it better for you. It means that if I try printing something like this, assuming, let's say, I've not counted them, but let me put 15 here, which I don't think will exceed. If I go ahead and print this, what do you think will be printed out? Suggestions. What do you think will be printed out?
The address of O.
It's an address of the index, guys.
Is it address? Remember that the percent specifier tells you what to print. Always remember that.
The full name will print.
Come again. But is it going to print the full name based on the explanation I've given right now? Is it going to be the full name? Are you sure?
It will.
Okay, so let's try it. Okay. So why is it printing the full name? That is the question. Why?
You said that
0.
once he prints the first element, then if the next one is not null, he prints it. Then he keeps doing it until he hits the null character.
Exactly.
Then he stops.
Exactly. So that is how we are able to print strings in C. Okay. So if you go and specify that this, then you have narrowed what it should print for you. Okay. So name to why is it not printing? That should be a question. Okay.
Because
Talk.
You see.
Come again. I was specifying a character in here. That's the English. I was specifying a character, not a string. So the format specifier has to be a character. Okay. There is one more thing I wanted to do. I think this the person who asked about the first question. The person who asked about what was it, the name of the string. I hope you get it. Goodness. I hope you find it right now. So if we go ahead and print it, just as I explained with this, it goes to the specific location and prints, kind of looping till it finds the null character. So once you introduce the null character there, that is what it's going to. I was going to do an illustration for us to see why the null character is important. So let's do the other declaration rather. Let's assume I did this and I didn't include the null character. Say O, comma. Probably this will be the last thing I'll be doing. E and D. Okay. So ideally, if you are defining it this way, you should end with your null character. If you are defining it this way, you should end with your null character. Then your computer, if you do it the other way as we did initially, say name is equal to. If I decide to do it this way, then the computer automatically attaches the null character. All right, but if we have it in this format, then you have to declare the null character. Okay, pay attention to that. So let's go ahead and print S. This prints that. Okay, let me now copy this, make a copy of it, and call this, let's say, first name. Then remove this null character and see what will happen. So for those of you who don't understand some of these concepts, these are things that you can be trying out. Okay, so let's see, without the null character, will it give us the same thing? Will we have a problem or not? So let's assume this is not even part of the case, right? Okay. What are we printing? Name. Let's print F name. I think something is wrong somewhere. Yes, this is what I wanted to show you. Cool. So what happened here? 5. Let me change this to, sorry, let me change this to 4 as well and show you exactly what I want. Name, F name. Okay. Then run this. Okay, good. So if you have observed something, F name, you see what happens? It goes to print. You can see from here that this is F name. Okay, but it goes to print the F name, which is Obed, and continues to print this one as well. But why? We are just printing F name. If I print name, it prints just Obed because it has just Obed in here. If I print F name, it prints Obed. So the question is why?
Because C expects you to explicitly include the cohort.
Thank you. So for F name, it's struggling to find the end of the character or the end of the string. Therefore, you have to put it there, because of the way you declared it. Once you are declaring it in the normal array format, you have to put the end character there. Because of that special end character, when we are working with strings, we can always look. You can always find the end of the string. Say you want to find the end of the string, you can use a loop that is checking if you have gotten to the end of the character, that is using the null character that you expect. Then you check and print out whatever you want to print out. So very important. If you are going this route, then you will need to be telling us where you want to end. Okay, very important. So assuming I deleted this and made it a character, then run it, then I'm getting the end of it. Okay, because it has found a null character. If it didn't find a null character, it goes on to print these other ones until it finds a null character to print. Okay. Final set of questions, please. Let me run away.
Doc,
sorry.
Doc, I want to
Yeah.
find out something. If we change percentage %s to percentage %c without putting a number, like where that F name is, without putting any square brackets where the F name is, will it print out the same thing?
So the best way to learn is what? Practice. Have you seen? I've done it for you. Have you seen?
Yeah.
Good. This is an address. It's an address to the location of this. Okay. So if you are printing character, it's not a character. That address is not a character. At least if you change it to maybe an integer, you may convert it to an integer and prints out the integer value. But it's not a character, and there's no character with this value. Once there's no character with this value, then you're not going to get anything. Okay. Any other question?
Okay, thank you.
You're welcome. Yes, any other question?
I want to ask.
Yeah, right.
Is it possible to declare using that using a pointer, declare a character string using a pointer? Like instead of that name and then square bracket 5, you just put char asterisk name.
It's also possible. All you should remember is that the name here is a pointer in itself. So if you decide to use a pointer to do it, I haven't tried it before, but it should work. Okay, but the question is, why would you want to do that? Okay.
Most of the tutorial videos I watch, that's how they do it. They just, if they don't put a square bracket or anything, they just put the asterisk and the variable that they want to name the string as.
Okay, that's also fine. I think I've seen what you are talking about. But once you declare it as an array, it becomes a pointer. So if I don't declare an array and I decide to call it as a pointer, that's also acceptable. I hope that's what you meant.
Okay, I get. So in that case, then you can now use it without dereferencing it.
No, this is just telling you that this name, wherever you see this name, is a pointer. That's all it's telling you. So if you want the exact value, you still have to reference it. A pointer is a pointer. It's only how will I, like this here is now telling you that it's just like I could have done this, say character pointer. Then I'll now come and say I don't know if they do this. I haven't seen this being done somewhere, but something like this. Okay, just like we did for other pointers. But wherever you see this, it's just a pointer to the location of this particular one. Then we can do the operations on them to get the other members of the string.
Okay. Thank you.
You're welcome. Yes, final set of questions. Yeah. So.
Okay, so Ben, I have a question.
Okay, sure.
Yeah, so for characters, like I saw you did there was a time you did just like this one, you did the obed without the commas.
Okay.
And then you named it as 4. Like the this thing is 4. The index numbers, yeah, there are 4 numbers. So does it mean that without the does it mean that it counts it as 4 characters even without the commas? Does it count it as 4 characters with each having 1 byte?
Yes. Because they are in this quotation marks, that's how he sees them. Okay, so this is like a syntax that it's already known that as soon as I see this, it's a string. In fact, when you go to any other programming language and we talk about strings, there is nothing like this. Okay, it's only C. Okay, I don't know about this. I mean, any other programming language that I know about, if you talk about string, is this. We don't have anything like arrays for strings. No, this is a string. Okay, so the compiler understands it that way. Yes.
I mean, in Java, I think we also have the
Okay. I don't know anything about Java, so I can't speak for it, but thank you for the information. So they are saying that we'll have a similar thing in Java. Okay, but I mean, the commonest thing is that strings are expressed in this way. Okay, so how will you see this kind of expression? It's usually like this. And once it's like this, C doesn't know strings. It just knows that strings are arrays of what characters. So each of them as a character. And this string name is pointing to just this location. And we can access each of them as a character. And each character reserves just a single byte.
Okay, so if it's a sentence like my name is Obed, will it count the spaces as a byte?
Yeah, they are also characters. In fact, everything on your keyword is a character. Or should I say almost everything, because the control key, I've not seen. So yes, let me just say everything on your keyboard is a character. Okay, so far as it's in there, except if you are using a special reserved something, like when you go and you use the null character or the how do you call it, the new line character, those ones have special meaning, so they will execute their meanings in there. But aside those specialized ones, every character you put in there is a character. So I can actually pass a number in here. I can actually write a number in here, 4. And it's not going to see it as an integer. It's a character. This means that it's going to focus on the, the ASCII value for 4. Okay, so everything that you type in there is going to actually grab the ASCII value. That's what it's keeping in memory. In the computer's memory, it's not keeping O, B, E. No, it's keeping the ASCII values of these ones. Okay.
So I have one last question. So since the surname is a pointer, will it still have the addresses? Like, since there are four characters. No, there are four arrays. There are four arrays in the pointer. I don't know if I'm correct with that. So would they still have their individual address?
Yes. So
like if you change it, like address of index 2.
Yeah. They all have their unique addresses. The only thing that makes them a string is that they are in a continuous form. So one byte here, the next byte contains another string. So the very first one, O, is contained in a specific address. Then the next one, the next location is 1 byte more. Okay, so your computer, just as we are saying, knows only strings. Only characters in this case. So your computer is just keeping, okay, let me pass the address of this to surname. That's all it's doing. But the rest, when I add 1 byte to the address of surname, I'll get the address of B. When I add an extra byte, I'll get the address of E. An extra byte, I'll get the address of D. So they all have the addresses. Like, they are all characters. If like we had something like a string, we would have said that, okay, the data type string maybe takes up this space in the memory of the computer, but we don't have anything like string. So the string is just a group of characters that are put together or adjacent to each other in the memory of your computer. That is what it means. So obed is actually 4 characters, but they are not stored at any location at all. The computer stores them in this way. Where it has stored obed plus 1 character, it stores H. Where it has stored O plus 1 character, 1 byte, it stores B plus another byte, it stores E. So it's in that continuous order so that you can access it anytime you want. And when you want to print it, that's where you'll go and check for the null byte, the null character. If it is not there, once it finds, prints the rest for you. That is how it works.
Thank you very much.
You're welcome. Please, we have an AMA session in about 7 minutes, so let's do all to join there. If you have questions, to take it to the AMA sessions. And also, you are in the Telegram group, so you are allowed to ask questions anytime that you want in there. Hopefully, tomorrow we are starting a new topic, in the ALX program. But today was supposed to be a PLD on recursion. Unfortunately, we couldn't meet last 2 days. Therefore, we are going to meet, God willing, on Saturday and discuss recursion. So let's try our best to do some reading on recursion before we come, so that we'll have a fruitful discussion. Thank you all for coming, and
Thank you very much. Go take care of your health.
You're welcome. All right, sure. Thank you.
Thank you.
Okay. All right. Bye-bye.
Thank you. Please help us to drop the video on the group because some